In part 6 of the Refrigeration Masterclass, we'll talk about how to maintain and operate a plant for energy efficiency. Energy savings opportunities here are the following, like the correct refrigerant charge, maintaining the evaporator coils, maintaining the condenser coils, maintaining optimum superheat control, checking fans and door seals, and replacing blocked filter dryers. Again, referring you back to the diagram that we had in the first presentation as to what these little devices are. So refrigerant charge, and oil charge too for that matter, is especially important for small commercial refrigeration systems because they are what we call critically charged or close to it. And too little refrigerant means that you're essentially starving your evaporator because there's not enough refrigerant going around, so you don't have enough refrigerant to fill your evaporator, which means your compressor has to run at a lower temperature at lower suction pressure to keep the capacity up so that your room can stay cold. Your compressor has to run for longer times because only half the evaporator is doing any cooling. And your compressor runs less efficiently because it's now running at a lower pressure. Now, if you overdo it and you put too much refrigerant in, the opposite happens. You have too high a head pressure and you have higher power consumption because of that, because now you've got your condenser half full of refrigerant. So getting the refrigerant charge just right is an important thing, and your refrigeration technician knows how to do that. These things, the changes in refrigerant charge are detectable if you have a system that is able to monitor it. So that's refrigerant charge, important thing to keep right. Dirty evaporator coils, as you see on this slide, are a major and a common problem, as the benchmarking study did show. So blocked coils mean that there's a resistance to the heat transfer, and you have to run the coil at a bigger temperature difference to achieve the same amount of cooling. So your system has to run at a lower suction temperature, otherwise you can't maintain your room temperature. And that same rule applies. If you have to drop it by 3 degrees, you'll get something like a 10% increase in power consumption, the 1 to 2 to 3 degrees rule. So the solution is clean or replace the evaporators. On the 3 photographs you see on the slide, the right-hand one is a really bad case of what happens to an evaporator in a seafood storeroom, or it could also be a small goods, because seafood with a little bit of salt on the seafood, or with small goods with a little bit of nitrates in the food, is enough to badly damage the evaporator coil very quickly, even within a few years. The other coils are either blocked with dirt or are just generally corroded and damaged. So all these 3 coils that you see in this slide would need to be replaced. You couldn't do much with them. On the other side, on the condenser, the same thing can happen. Blocked or deteriorated coils will not transfer the heat well. So to get rid of the heat, the head pressure has to rise, and you have a higher energy use as a result. Again, because of the 1 degree higher, 2 to 3% greater energy use rule. So again, clean or replace the condensers. The 2 photographs on the left, the one shows corroded coils that are falling in on themselves, and the other one is a coil that's full of spider webs, which is quite common, or fungal growth for that matter. Then I've got a photograph here of another site that I visited on my travels through Victoria, and that is a site very close to the sea, and you can see the coils are basically gone, completely demolished by salt water. So aluminium finned condensers near the ocean is generally not a very good idea. Superheat control. This is something a technician learns in the first few months of his apprenticeship, is how to set superheat on an expansion valve. What is superheat exactly? If you put too much refrigerant into a coil, you actually get liquid coming out the end, and compressors don't like liquid. So you want to be sure that the refrigerant is fully evaporated inside the coil. And you do that by just putting enough refrigerant into the coil so that by the time it finds its way out the other end, all the liquid is gone. And the expansion valve measures the amount of extra heating that is put onto the refrigerant before it leaves the coil. Now, if you overdo that and you put way too much heat in there, it basically means that potentially half the coil is dry and only half the coil is actually full of refrigerant. The rest of the coil is used to heat up the refrigerant, and that is inefficient. So your compressor becomes less efficient, and you have a smaller evaporator. So excessive superheat reduces performance. Insufficient superheat will potentially damage your compressor. So it has to be optimally set. And yes, the safe setting for a technician who has to do a quick install is to set a very high superheat so he doesn't have to come back to the site. But it's not what you want as an owner of a system. So you have to get the superheat settings right, and that takes a bit of time. You have to put your pressure gauges on there, and you have to put a temperature sensor in there, and you have to adjust it and wait and adjust it and wait, and it could take an hour or two to properly set the superheat. And if you don't have an hour or two, you might not get there. Filter dryers, those little units I showed you on that slide in the first presentation, these are used to filter the liquid. Now, there shouldn't be dirt accumulating inside a refrigeration system, but still, when the system is installed, there could be a bit of dirt in your system, and that all gets caught up by the filter dryer. But what the filter dryer also absorbs is any moisture in the system. And if somebody opens a system to replace a compressor, for example, and closes it and lets a bit of moisture get in, that moisture will be absorbed by the filter dryer, which makes it expand a little bit. The stuff inside, it's like this desiccant you have in your clothes, with your clothes. It absorbs a bit and it creates a pressure drop. Now, that is more common than we thought. There were quite a few sites out there with blocked filter dryers. That acts like an expansion valve. So what happens if a filter dryer is blocked, it actually becomes cold at the one end. So it's something that I tell my clients, put your hand on either side of the filter dryer, and if you can feel the one side is warmer than the other, you have a blocked filter dryer. And it is a constant, like a throttling effect on the refrigeration plant, because you're not getting enough liquid through the filter dryer off to your expansion valve. So you notice it by having the outlet of the filter dryer somewhat colder, so it's relatively simple to pick up by hand even, or you can monitor it. But you can't change a filter dryer yourself. That's something you need a technician to do, because you have to open up the refrigeration system. So that gets us to recommissioning and tuning, and this is an opportunity in itself. Referring back to the benchmarking study, we know that 70% of the smaller refrigeration systems on average would be faulty, would have some problem with them. So the chances are 70% that by recommissioning your refrigeration system, you will have an energy benefit. Without even having a look at it, there's a 70% chance of having a gain. And the sort of things that you'll look at would be coil defrost, making sure that that is properly done, preventing short cycle operation of the compressors, controlling the head pressure so it's at a reasonable level, controlling the low pump down pressure, which I've mentioned a few times, and the process of doing that is called recommissioning. So defrost. Remember the early slide where a big chunk of the energy was used by the defrost heater? We have to use defrost heaters when it's a freezer, because we have to put heat into it. Even if you turn the refrigeration off, the ice is not going to go away. And even with most cool rooms which run below 4 degrees, you still have to use electric heaters to defrost. If your room runs at 10 degrees, you can do what we call off-cycle defrost. You can just turn the unit off and the air temperature will eventually melt, or the heat in the air will cause the ice to melt. But for most cool rooms and freezer rooms, you have to actually have an electric defrost heater. So the default is industry standard. Default is 4 defrosts a day, every 4 hours for half an hour or for 20 minutes. And that's what most people do. They'll set it at half an hour, 4 times a day, and that's it. Now, is this enough? Is it too much? In most cases, it's in fact too much. So what you do, if it's too much, it means you're over defrosting. So you're putting heat in there half the time that you're putting heat in there, the ice is long gone, and what happens to that heat? It just heats up the room. Heats up the evaporator, heats up the room, and then your refrigeration system has to pull all that heat back out again. And you do the same thing again 4 hours later, and you do the same thing again 4 hours later. So that's what's called over-defrosting. And it varies from one room to another. Rooms that are constantly people going in and out, well, maybe half an hour every 4 hours is not even enough then. So it is something that needs to be observed and fine-tuned for every application. So if it's too long, you get the extra load. If it's too short, you get a build-up of ice over time, and then the defrost doesn't even work anymore. Then you have to really do a hard defrost, go in there with a hose and get all the ice off. So fine-tuning it is something that can be done. The owner can pay attention to that, by looking at the coils, which I encourage everybody to do anyway, because you need to look at your coils from time to make sure they're clean. You can also see whether they're actually accumulating ice. And if you have a system that monitors the coil temperature, you can then see whether there is a build-up over time. Short cycle prevention. This can happen for various reasons. If you have your room thermostat set way too close, let's say, for example, you've got a cool room and you set it between 0.5 degree and 1 degree. So whenever it reaches 0.5 degree, it turns on. When it's 0 degree, it turns off. There's no reason for that. You don't have to run your cool room within 0.5 degree. But if you did that, then your compressor would be on and off far too frequently. So setting the thermostat incorrectly is one way to get short cycling. Setting the suction pressure incorrectly is another way of getting short cycling. So this is really parameters, even on an on-off control, setting simple things like the thermostat correctly can make the compressor run an acceptable length of period on-off, minimizing short cycling. So you could be out of luck, and it could be due to oversized compressor. And then your only solution might be to add a speed drive to slow the compressor down. But if your compressor is not oversized, then a simple control adjustment should be able to avoid short cycling of your machine. Right. Head pressure minimization. Most systems, even the simple on-off control systems, when the compressor comes on, shortly after that the fan comes on, or perhaps the fan even switches on at the same time. On a very simple system, the fans and the compressors always run together. On the slightly more sophisticated systems, there's the HP switch, which will then, or the fan control switch. When the pressure gets high, it turns the fan on. When the pressure is low, it turns the fan off. Now, if you set that pressure too high, then the fan will cut in very late, and your compressor will run at a high head pressure always, because it'll always wait for that pressure to build up before it turns on. Now, why would anybody set it like that? Well, this could be because there might be a fault with the expansion valve. Remember I mentioned the expansion valve needs to have enough liquid pressure. If for some reason the contractor might have put a very small expansion valve in there, how does he fix that? Well, he can either replace the expansion valve, or he can set the head pressure high. So on the benchmarking study, we found quite a few sites that were running at a very elevated head pressure, probably because they fitted an undersized expansion valve. So the fix is not run it at a high head pressure. The fix is replace the expansion valve. So these are things that you can detect, and that a recommissioning should identify that, replace the expansion valve if you have to, and then get the head pressure back down again. So recommissioning solves all these problems if it's done competently. So you optimize those LP and HP settings on the unit. You optimize the TX valve adjustment, so you make sure that it sits at an optimal value. You optimize the defrost control set point, or the timing, so by observing the coil and not over defrosting or under defrosting. You check the refrigerant charge levels, and you also generally look at the way the system operates, and that gives you a very good outcome. Now, last thing in this presentation is about aftermarket add-ons. Because refrigeration is a bit of a black box. And because there's so many things that can go wrong with refrigeration, and there are so many things that influence the energy use of refrigeration, it's easy to baffle people with science. So refrigeration, more so than any other industry, is vulnerable to, I call them the snake oil salesman. Okay, and there are technologies out there that I keep alerting people to that are always out there, the magic bullet, the quick solution, the quick fix, and we need to be careful. So, beware of the quick fix. With refrigeration, there is no quick fix. There is no, if your refrigeration system is not running well, you got to do the hard yards of recommissioning it properly, checking the design. There's no quick fix. There's no something that'll go there and drop the energy use by 40%. If anybody tells you that, then they're lying. So there are a lot of unproven systems out there. And we've been in the business long enough, and we are confronted with these. Are presented to us, you're a consultant, couldn't you sell this to your clients? And then we ask the few questions. Now, many of these systems just simply do not work. And some of them actually do damage to the refrigeration system. There are some of these solutions that have a short-term gain for long-term pain. They will, even for a short, brief period of time, save energy, but then they will cause damage, making you have to replace the system before its time is over. And most of them, of course, are expensive because somebody's trying to make money. So, yeah, old rule, if it sounds too good to be true, then it almost certainly is. So what are we talking about? One common product on the market, and it takes different colours and shapes, is oil additives. Various additives, they call them oil additives, sometimes they call them refrigerant additives. And they claim to work by either reducing the friction in the compressor or by removing oil and dirt from the evaporator, making the system more efficient. Now, if you think about either way, something that reduces the friction in the compressor is probably like a thin oil or something. Does that do any harm to the compressor? Almost certainly it will. And very few of these oil additives, if any at all, are actually approved by any of the compressor manufacturers, for example. And the refrigerant, the cleansing agents, the detergents that clean the evaporator, they may clean the evaporator, but they also clean the compressor and remove all the oil from the moving parts of the compressor. So neither of those are generally approved by any of the equipment manufacturers. So they may have a short-term benefit, but you'll probably be replacing your compressor very soon after. Then there are various aftermarket coatings. They'll come in and they'll spray a coating on your evaporator and you won't have any ice anymore. Now, that's not even theoretically possible because if you cool air down, the ice has to go somewhere, right? If you take this air and you cool it down to 0 degrees, the moisture can't stay in the air. It's got to go somewhere. Now, these coatings do actually do that. They do repel the ice from the surface. But all that happens is that the ice goes deeper into the coil because it doesn't penetrate all the way in. So you have a deep ice formation further in the coil, which is then harder to defrost. So there's no benefit in that. But in short term, after they've applied it, there's no ice. Oh, yay! But you don't have the benefit. And so it goes on. There are aftermarket condenser coatings. We've had a scam a while ago of this company selling like blankets that you put on the inside of a cool room, silver blankets, and they drop the power by 20%. Now, we actually were instructed to test those by the New South Wales government, and we found no detectable benefit. I mean, not even theoretically would there be a benefit, but we did the test and found no benefit. Then we get more left field things, like a while ago there was a scam where they sold you magnets, clip-on magnets, which go around the liquid refrigerant line, which magnetized the refrigerant and made it improve the performance in the evaporator. And then we had the special valves, the blue valves, which you install between the solenoid valve and the expansion valve, and they were designed to turbulate the refrigerant so that it also wetted the evaporator better. And I know a lot of supermarkets were conned into that. You can even go to some of the supermarkets, not the big ones, some of the independents. Many of the independents I go to now, and bang, I see the blue valves there. And they're like $1,000 a pop. And there'd be 50 of them in a supermarket. So they definitely don't work, right? The latest was a drop-in refrigerant where, R22, the one refrigerant that is now completely phased out, still a lot of it around, you can buy this drop-in which gives you an instant 30% energy saving. Now, as a thermodynamics guy, that really annoys me because R22 is actually one of the best refrigerants we've ever had. It is really hard to build something as good as an R22 system. Everything is less, all the other new gases are not close to it. And these guys come up with a concoction which is 30% better. Like it's not even possible. So there are all these systems out there, and we've recently had a spate of systems which use solar energy to boost the efficiency of the refrigeration system by heating the gas after it comes out of the compressor. So the thermodynamics makes no sense, but these systems are being sold, and unfortunately I've seen one or two IGAs also buy that. So it's unfortunate that people are being misled into doing this because it gives energy efficiency a bad name. There are practitioners out there who are really trying to put systems in place that save energy, and then we have the guys come along and sell an energy efficiency tool which doesn't work. And then that client will never look at energy efficiency again because he's been burnt. And that is the bad outcome with these systems. So, if you're approached by anyone purporting to sell you a reputable system, check whether this influences your equipment warranties, first of all. Give your manufacturer a call and say, does this product void any of my warranties? Then, can the vendor supply you with certified results? Has proper measurement and verification ever been done on it? If so, there will be a report, there will be third-party results. Give me the third-party results. Has the system been included in the standard specs of the large retailers? They're pretty thorough at scrutinising any offers, and they're very conservative. So if the big retailers are using that technology, you can pretty much rely on that. And can you actually calculate the exact savings? Now, a typical technique that most of these guys use is they arrive at the sales meeting with a folder full of references, full of reference letters from various sites all over the world where the guy will have written, I got all this energy saving. So that's the strategy, anecdotal evidence of energy savings from this collection of letters. And generally if I see that to me is already sufficient evidence that the sales process used is not thorough, it's not supported by factual engineering evidence. And then finally, of course, from an engineer's perspective, I like to have a tool. I'd like to say, okay, if I use your technology, I'm going to save 8.7%. And if I can't calculate it, then I can't present it to my client either. And so those are the three things. And then finally, which normally works to get the vendor out of my office, is I say, can you provide me with a full cash refund if the equipment doesn't work? And that's normally the best argument. So yes, very, very important to be very careful as a buyer of many technologies out there. Thank you very much. Sustainability Victoria supports action on climate change and reducing energy costs. If you would like to find out more, please visit the Sustainability Victoria website.